All right, shall we get started then? All right, well, welcome everyone. We're so glad that you could join us for this important webinar on privacy enhancing technologies for official statistics, which is a side event of the 54th session of the United Nations Statistical Commission. I'm Jess Stahl, Vice President for Data Science and Analytics for the Northwest Commission on Colleges and Universities, and I'm also a member of the UN Task Team on Privacy Enhancing Technologies, often referred to as PETS, P-E-T, of the United Nations Committee of Experts on Big Data and Data Science for Official Statistics, a member of the UN PET Lab and Open Mind. I'll be moderating the webinar today as we hear from leaders of national statistical offices about the important role of PETs in unleashing the potential for great societal and economic benefits arising from the use of trusted, relevant, timely, and high-quality data. Also, during this event, experts of the Task Team on PETs will launch the UN Guide on PETs for Official Statistics. There will be time reserved for questions after the presentations have concluded, so we ask that you write any questions or comments in the chat throughout the presentations, and we'll respond to as many of those as possible at that time. Also, this webinar is being recorded, and the recording will be available on our website after the event, where the guide is also available. We'll place a link to the website in the chat. And now I'm very pleased to introduce Mr. Stefan Schweinfest, Director of the UN Statistics Division.
Thank you, Jess, very much for leading us into this exciting side event. So I'm Stefan Schweinfest, the Director of the UN Statistics Division. Probably most of you know my dear colleague, Ronald Janssen, who is leading this work in our office. So Ronald came to me and he said, you have to be there tomorrow at the opening of this. There are going to be hundreds of people. And we are going to launch the PET guide. So, I mean, he definitely got my attention. But I think he's definitely right with the numbers. We are in the triple digits here this morning, afternoon, evening, all over the world. So I'm very happy about this. And I'm really very pleased to be part of this launch of the new form of collaboration, new form of product, which is the United Nations Guide on Privacy Enhancing Technologies for Official Statistics. Now, we like our official statistics. We have the sign hanging out there, Statistics Division, and what we do is, of course, working with all of the national statistical offices around the world, helping them to produce the official data to cover and describe their countries, all of the dimensions of their country, the economy, the social dimensions, the environment. And we are doing it, of course, as a UN Statistics Division. We are trying to facilitate to have normalized international standards, guides, so that everybody is doing it the same way. But I always say norms are not a straitjacket. Norms are actually also a help and a vehicle to exchange experiences. And I mean, what you have been doing is just one of those wonderful examples how we can help each other in a new and challenging area. So I think the Statistical Commission, these are the heads of the national statistical offices, they will meet here in 2 weeks. And those heads of the national statistical offices, they are at the same time our bosses here in New York and our customers. I mean, they come together as an executive board once a year and look at what are the areas that we need to be working on. And then when we work on this, we work with them during the year. And what we do very, very well when we identify a new area is then we create a committee. And then the committee create task teams. That we are excellent in doing this. And that's the form of working together. And that's exactly what happened here in 2014, almost 10 years ago. Already we realized that we needed to pay attention to the topic of big data on official. There is a lot of information out there, but is it all good? What can we use? How can we use it? So we said we can't figure that out alone. So we created our UN Committee of Experts on Big Data and Data Science for Official Statistics, always again. with the purpose of creating numbers that support our policy decision making all over the world, national, global. And that mandate of the committee is still very relevant. We've been working very, very hard over the last 10 years, but it's the situation, if anything, has become even more challenging. Every day there are more tools out there, there's more information out there, and we need a common reflection of how do we translate into really solid national and then global information to support all the important decisions we have to make. And then, of course, under this committee, we had the task team that was working very, very hard. And the end result is this PET guide, Privacy Enhancing Technologies. And that is obviously something that we couldn't do alone. So it wasn't just official statisticians talking to each other. Now we opened the door for big partnerships out there with the private sector, with academia, with civil society, and many of you are here today and have been contributing. This is cutting-edge innovative work, and I wanted to really thank you that you helped us to address these critically important issues on privacy issues, security, and IT, which is perhaps not originally our forte. That's why we need these partnerships. And I know all of you, whether you are in the private sector or in academia or in civil society, you have daytime jobs. So contributing to a United Nations task team and to the global betterment of solid information systems is a noble gesture, and I'm really grateful for that. In our community, we have something that we hold very dear. That's our fundamental principles of official statistics, sort of a little bit our 10 commandments. They are now 30 years old. And this is basically our codex, our ethical principles, and how do we work with citizens. And I would, if I could describe it in one sentence or two, I would say there is a fundamental deal. The national statistical institutions, they get the information from the citizens, but treat them with a strict confidentiality for the exclusive use of statistical purposes. And so I think, and to also satisfy citizens' entitlement to information. So that's the fundamental deal, getting the information from the citizens and feeding it back in the appropriate manner, aggregated, quality checked, integrated to the citizens so that it can be used by the entire society. So, and you have been helping us to do this in a very modern way, to continue doing this, to stay relevant. And I really wanted to thank you all for this and for the PET guide that we will have now. And I wish you a good event and an enjoyable interaction with each other. So thanks for having me here. Floor goes back to you, Jess.
Thank you. And now I would like to introduce Mr. Ron Jarmin, Deputy Director and COO of U.S. Census Bureau, for some introductory remarks.
Thanks, Jeff, and thanks, Stefan. And good morning, everybody, or good afternoon or good evening, as the case may be. But it is morning here, and I've been drinking coffee, getting ready for this. So I'm absolutely thrilled to be here to talk to you guys for just a couple of minutes this morning, and to see the progress that we've made on privacy enhancing technologies. And so let me start off with a little something I said to my chief information officer a few weeks back. I said, Louis, your job is evolving from what the CIO of a statistical agency used to do would be to acquire IT assets, get them installed, provision those to the subject matter experts in the statistical agency, so they could compute on the data and then release the statistics to the public. And I said, your job's evolving to being a node on the internet, a node where we can get secure access to information, maybe not move the data, get secure access, compute on that data, and then give new forms of access, not just tabulations that sit in static tables on a web page or, formerly in bound books and libraries, but new ways to give data to users, to researchers, maybe even to some of our respondents, especially our more sophisticated respondents like the business community. Can we find ways to do that? So I said that this really is a whole new paradigm that we're moving into, and pets are at the center of that. So I just want to kind of start with that. Just like it's a complete shift, I think, that we're seeing in official statistics of not just doing a survey or getting some administrative data and tabulating that stuff up and putting it out there for the user to use without a whole lot of knowledge of what the user wants to do, but really more being part of this value chain of queries that are intended to solve specific problems that we then go out and scour all of the available data that could address that query, whether that be survey data, whether that be administrative data, whether that be data that we acquire from some third parties, or whether it's kind of data in the wild. And so there's a whole host of projects, and hopefully folks have had a chance to peruse the volume, but we need to get more people out there looking at this guide to see the wealth of examples that we already have of how pets can be used. And so I guess I'm here as a cheerleader. And so but so what are the things that people tell me, data users tell me, and I hear it all the time. They want more granular data, whether that's by geographic location, whether that's by various characteristics like demographic characteristics or business characteristics, or the types of environmental conditions that are on the ground in a particular location, and they want more timely data. And so from the view of official statistics, that our traditional production function of doing surveys, tabulating the results, even if we didn't have the challenges with survey data collection that we all have encountered over the last few decades of declining response rates, increasing costs, even if we didn't have that, you couldn't meet our data users' objectives with survey data alone. So we're already in the business of needing to find new source data. So, if we look back, all the improvements in official statistics are always attached to some improvement in the source data. We have increasing amounts of computational power and the ability to securely access information in ways that were unimaginable even 10, 15 years ago. Okay, so these technologies are kind of coming online, and they're going to open up a whole sort of range of possibilities to us. And so I think, and they're in two directions from the official statistician. So we kind of sit in the middle of a value chain, if you will. And so we need to get secure access to information that currently resides either in private sector data lakes or in other government or across each other. Okay, so one of the examples that we've been participating in the Pet Lab with is looking, can we do better trade data by using some of these technologies to combine information from several different countries? So can we find ways to get secure access to information that we can then compute on that information to produce the statistics we need? But then on the flip side, our users want more granular, more timely data. And one of the challenges that we face is as Stefan said, we have this value of protecting the privacy and the confidentiality of the information we collect. Sometimes there are statutes attached to that privacy and confidentiality. Sometimes it's just a good practice. So how can we deliver more granular, more the ability for people to do analyses that they can't do from traditional stat agency publications? And I think it's again back to these same technologies. And so one of the things that we did with our recent population census in the U.S. was we moved to formal private methods for doing disclosure avoidance for the decennial census. There was a lot of controversy around that, and so I think one of the lessons that we have from that is that this value chain is evolving, and if we're going to be able to produce the kind of granular information that data users want, that data might not be what they're used to using, and so part of this is we really need to have the data user in mind as we're contemplating using these technologies, and I think in particular the use case to which the data are being produced. So one of the we're trying, like all of us, we're all trying to transform and modernize our operations, and one of the things that we're focusing on at the Census Bureau right now is really thinking about the data user first and what is the question they're trying to answer. So I think that the Census Bureau and specifically, but other statistical agencies around the world more generally, we've been kind of lazy about this, right? So what do? We get some data collection, we tabulate the results, and we throw it out there for the data users to do what they will with. Well, from a privacy perspective, that's a very costly strategy. Okay, and so I can give someone much more accurate answer to a query by computing on the data behind a secure firewall, perhaps using some sort of privacy enhancing technology, and giving them the answer, a very accurate answer, more accurate than I could give them if I had to give some general purpose data outside the firewall and let them compute the answer to the query themselves. And so I think we need to think about this whole value chain. And I think statistical agencies have been, we think about collection on the front end, we think about processing in the middle, and then we shove the data out the door and kind of let users do what they want with it. I think we need to think about that full value chain now. Privacy needs to be baked into all of that. But the key is, can we give the user a accurate answer and a timely answer to their questions? And I think that's what's got to guide all of our work on this. And so, there's a host of technologies that the report discusses, from differential privacy to secure homographic computation, all these different things. I'm not the expert in these, but fortunately we have some experts that have been working on this. But I think one key thing is that we don't have enough experts, and so let me just end with that as we move forward, we're going to have this need for more experts working on this, and statistics is not just a domain now for statisticians, for survey methodologists, for demographers, for economists, for sociologists. It's now a domain for engineers, and we are doing things in the U.S. context where we're trying to work with universities to increase the pipeline of these folks, but we obviously face a lot of competition in the public sector trying to get these folks, because they go work in the private sector as well. So I think increasing the pipeline of talent throughout the world that are folks that work on these problems is something that's going to be probably the long pole in the tent going forward. That we're just not going to have enough skilled folks to bring this sort of vision to fruition. So I think that's going to be a huge challenge that we're all going to have to work on, in addition to making progress on using these technologies in specific use cases. So I'll end there. Looking forward to hearing more about the report, and looking forward to sharing it with my colleagues here in the U.S. So thank you very much.
I want to thank Mr. Schweinfest and Mr. Jarmin for framing the great potential and importance of high-quality data and privacy-enhancing technologies for official statistics so well. And now, to support the efforts of national statistical offices around the world, we are launching the UN Guide on Privacy Enhancing Technologies for Official Statistics. Please welcome Mr. Matthias Jug, Chair of the UN PETS Task Team and Head of CIO Office, Statistics Netherlands, who will now officially launch the publication by providing an overview of the guide.
Yeah, thank you, Jess, and welcome to everyone. I unfortunately don't have champagne with me to throw it to some wall or something like that. But I will just provide you a little bit of history behind this guide. So this document is next version of the UN handbook for privacy preserving computation techniques that was published by the same task team in 2019. And actually, that document was already very inspirational, and it had quite a life. It made quite an impact already. And then during the COVID period, the privacy, I guess, became even more important. First, because we need to find new data sources as statistical community, as Ron mentioned. But second, also because the public perception of privacy and concerns around that even increased during that period of COVID. So we decided to release the new book, but we set up a challenge to actually go beyond just description of those techniques. So we collected very practical case studies to show and help organizations to see how this can work in practice and what organizations around the world already are doing and what have they achieved. But also some guidance how to use these technologies. So, for example, which are the standards that are available that you can use to help with the implementation of these techniques? What are the legal requirements or legal perspectives that you need to consider, and how this is working in practice? So this means that this guide is much longer document than the previous one, and you will probably not read it from first to last page in one go. So it's even though that we don't have anything against if you do, but this is probably a reference guide, which you can use to go and look into the similar use cases that could help you to identify the right techniques or right combination of techniques, or use it to try to find the partners that you can work with, etc. So to help you with this initial insight into this guide, we will give you a short preview during the next couple of minutes in main 5 chapters of this guide. But before we start with the presentation, I would like to thank first members of the editorial board who actually organized the drafting and review of those chapters, and will be presenting in a minute. Then I would like to thank more than 20 members of the Privacy Enhancing Technologies task team who contributed the content, and I would like to also thank more than 100 external experts who contributed either via the selected case studies or via the reviews. So with that, I think we should start. Jess, back to you.
Thank you. I would now like to introduce Mr. Ronald Jensen, Assistant Director of the UN Statistics Division, for an introduction.
I think Ronald might have just dropped. He was having a bad connection.
Sure, no problem. Let's move forward into discussion of the methodologies section of the guide. And I'd like to introduce Mr. Jack Fitzsimons, co-founder of Oblivious AI in Ireland, and Mr. Robert Pisarek, co-founder of Oblivious AI, also in Ireland, who will be speaking about the methodologies.
Thank you, Jess. I'll just share my slides. So I would like to say a few words essentially about privacy enhancing technologies, or PETs. So what do we actually mean by this term? What are the main PETs currently available? What considerations should be taken into account before we use them? And in the end, what they can be actually useful for. So as Ron already mentioned, kind of the the high-level challenge that PETs really address is essentially being able to process more fine-grained input data, to have better and more nuanced statistics, while at the same time protecting the privacy of underlying people and businesses. Right? So then this is, of course, particularly important when we're dealing with sensitive data. And PETs help with that in kind of three major ways. So firstly, they are allowed to combine data from multiple data sources. So this can be even from different organizations that want to collaborate without essentially exposing sensitive information to each other. Secondly, PETs can provide guarantees that data is only used for specific pre-approved application and never outside the scope of its intended purpose, right? So in this way, PETs essentially act as a technological and in some cases mathematical guarantees in addition to the typical legal ones. And finally, PETs can be useful when sharing and disseminating data, essentially offering tools to prevent reverse engineering of original sensitive inputs and data from the aggregate statistics that is then being more widely shared. And of course, there are kind of a lot of different PETs. So maybe it might be helpful if I introduce kind of a typical setting to categorize them. So in a typical kind of data processing context, we can essentially break any process into three straightforward distinct parts. Right? So you have the input, the data, then we have a function or a computation that acts on that data. And of course, out of the computation, we have the outputs. Now, different PETs help to protect different parts of that data flow. And most of them can be broadly categorized into either input privacy or output privacy. Now, input privacy is about how to protect the input data while it's being processed. So again, the example of that is, two or more parties that want to run analytics on a joint data set without directly sharing their sensitive inputs to each other. While output privacy is very much kind of concerned with limiting what can be actually learned about the inputs from the outputs of the computation, right? So once we have the output of the function. So maybe let me now talk a little bit more concretely about some of the PETs that we actually cover in the guide. So input privacy first. They're essentially very exciting because they can essentially offer things that you couldn't really do up until now. There are mainly two major approaches to input privacy. The first one is purely cryptographic methods based on so-called homomorphic encryption and secure multi-party computation. So homomorphic encryption has been the holy grail of cryptography for decades until 2009, when the first so-called fully homomorphic encryption scheme was proposed. And it essentially allows for direct processing, addition and multiplication of encrypted data. So data stays encrypted even during the processing. Secure multi-party computation is kind of a broad term that includes a range of techniques that allow multiple parties to process encrypted data. So again, these cryptographic approaches are extremely exciting because they offer very strong security guarantees based on computational or information theoretic assumptions. So there's a very active research community, a lot of cryptographers working on that with open source libraries covering different specific protocols for either fully homomorphic encryption or secure multi-party computation. However, there are of course also challenges. One of the major one being that computation can be unfortunately painfully slow. So it's slowing the kind of the typical process by many orders of magnitude, or they can require, for example, large communication bandwidth as well. Furthermore, they kind of often require applications to be rewritten from scratch and adopted to specific requirements of those new frameworks, which is of course kind of far from being straightforward. And the kind of the final thing that we also talk about later is that as these are new technologies, there are also limited kind of standards and audits available for them. The second major approach to input privacy is through so-called trusted execution environments, or secure enclaves, or confidential computing. It's three different names, but essentially the same thing. So enclaves are kind of a new type of a server with two main properties. Firstly, they're isolated from the rest of your computing environment, with very limited input and output. And secondly, the infrastructure provider, typically the cloud or a chip manufacturer, can guarantee the code being run within them through a process called cryptographic attestation. So essentially, the encrypted data can be sent to this isolated environment and decrypted within it for a specific pre-approved purpose. So the advantages of enclaves are that there's almost no computational overhead, as the data is actually being processed in plain text decrypted within enclaves. As also as it's built from kind of standard, well understood security primitives, they can have all the kind of required certifications from FedRAMP and whatever you might want. And they're also now widely available by literally all major cloud providers, and also all the main kind of chip manufacturers have enclave offering as well. The challenges, though, are that you have a different trust model. So you need to trust now a physical infrastructure, either a chip manufacturer or a cloud or a combination of both. And because of that, there are also side channel attacks on enclaves, which have security considerations. So maybe let me now move to output privacy methods. There's essentially kind of basically disclosure controls. So I'm sure everyone here is very familiar with traditional statistical disclosure controls that involve a number of different anonymization techniques, aggregation, and grouping of data. And these are, of course, very well understood, have been used by the statistical community for decades, and of course, as such, are very well tested, have multiple standards, and are, because of that, often easier to use. Unfortunately, there are challenges, like with everything, so they can be subject to multiple re-identification attacks, such as linkage attacks, where the attackers can exploit additional information about data sets to de-anonymize data. And unfortunately, these are often impossible to protect against, as most of such techniques don't really offer provable guarantees. But on the other hand, so differential privacy is a kind of a fairly new disclosure control that was proposed in 2006 and has such guarantees, right? So it works by perturbing or adding appropriate level of noise to the output to bound the information that can be learned about any individual in the underlying data set. So the level of noise added to that output is then controlled by a parameter called privacy budget or epsilon. So this is very handy because essentially provides mathematical guarantees around privacy laws. And with that, you can track the total privacy loss over multiple releases by simply adding epsilons. Now, again, we have challenges, and the main one being that choosing this kind of appropriate level of noise added to the output needs to be kind of carefully done. So it needs to balance both the accuracy and utility of the end of your data and privacy. So that's a non-trivial task. And of course, the framework is also new and non-standard, which poses its own challenges. Maybe let me say also just a few words about a couple of other techniques. So synthetic data is yet another output privacy technique that many people might be familiar with. And it's essentially creating fake data out of real data that is similar under kind of certain characteristics or properties or correlations to the underlying data set. There are, of course, different ways to build synthetic data using machine learning models and generative models in particular. However, synthetic data per se doesn't really provide formal privacy guarantees. So what you need to do is you need to introduce a differential privacy step during its generation. And with that, again, you can control the privacy loss through epsilon, through this kind of privacy budget. The great thing about synthetic data is that once you create them, you can freely reuse them, you can disseminate without incurring any additional privacy loss. And as such, they're very useful, for example, for testing. However, this is at the same time occurs because if you don't know what questions, for example, you want to ask in advance, those synthetic data might not reflect the true characteristic of the real data set. They might have biases and so on. Finally, distributed learning can be considered as an input or output privacy technique. But what it does, it kind of aims to train machine learning model, neural network in particular, on input data that is owned by multiple parties who want to keep their data private. Right? So the training happens also with the assistance of a central sort of trusted authority. So this has gained a lot of traction due to the likes of like Google and Apple, who'd really like to train models across millions of devices. Right? So with that kind of distributed learning and in particular federated learning can be very useful for the specific training tasks. And they work very well in the case of like large number of nodes. Again, it doesn't itself provide specific privacy guarantees unless a differential privacy step is included within them. So hopefully, you see that kind of PEDs are a fairly broad category, and the guide that just came out discusses them in much more detail, of course. It also covers kind of costs of using each technology, security models involved, example use cases, and so on. Nevertheless, one thing to stress is that there is no single pad that solves all your problems, right? So for each application, choices need to be made depending on specific circumstances, from the number of parties that are involved, the size of data set, whatever computation is involved, and so on. So actually in the next presentations, I think the colleagues will also give you kind of use cases and example of practical considerations involved when deploying those pads in real life scenarios. Thank you.
Thank you so much. And now I would like to introduce Mr. Matjes Jug, Chair of the PEDS Task Team and Head of CIO Office, Statistics Netherlands, and Mr. Dave Buckley, Senior Technology Policy Advisor with CDEI, United Kingdom, who will discuss the case studies.
Hello, everyone. I hope, yeah, you can see my screen. So, yeah, we will start with, we will continue, sorry, with the chapter 3 case studies. So as I mentioned earlier, we received, collected, and published 18 case studies, concrete case studies. They're coming from statistical organizations, but also other organizations, and also for cross-organizational projects where a lot of organizations work together on these techniques to be able to share data in a secure way. But I will start with some statistics. From these 18 case studies, we have examples from 8 different jurisdictions. So they are really from all around the world, from all continents practically, and of course they cover various spectrum of techniques or PEDs. So here we see that multi-party computation was quite popular, and homomorphic encryption as well, and differential privacy. And then we have also examples of case studies with trusted execution environments, the federated learning, and synthetic data. Now, this is not, how to say, statistically representative. We have too small number of case studies, but it shows which case studies work in which, which techniques work in which settings. Then we also see the kind of area maturing. So we have examples of course, proof of the concept stage or pilot stage project, but we also have 3 case studies that have been in full production now for several years. And in terms of the scale, so we collected certain case studies that have been done within one organization, but we also have case study that have hundreds of organizations as input parties. So I'll go a little bit to explain how we, which methodology we used in this part. So on the right side of the slide, you see first the table with first 5 case studies from our selection, and you can see that we organize them according to purpose. We specifically describe the data sets that they use, of course, which PEDs are used, what is the application of these PEDs, and implementation status. But maybe even more important, we have collected in a very structural way also the parties and their relationships. So who are input parties, who are output parties, what is the trust between them, which can help to identify certain more generic use cases. For example, what we came upon quite often was privacy preserving statistical analysis or privacy set intersection with analytics, which has multiple data sets often owned by, for example, public organizations, NSOs, or academia, and then there is a need to have privacy preserved application of analysis for public good. So this is one example that came quite often, and then you can see, of course, from these practical examples, which techniques are used, what are the issues they faced, etc. Then we have case study descriptions for all of these case studies, but probably most important, we ask them to provide outcomes and lessons learned, both from technical perspective, but also from organizational or legal perspective, for example. So this is one example of such a case study, which was provided by a partnering project. So there was a project which is now finished, UNECE Input Privacy project, which was a collaboration of several statistical offices that explored the input privacy techniques for several statistical use cases. And this is one example, which is also interesting because it is about relatively novel technology, which is federated learning, which is application, secure application of or training of machine learning model on distributed data. Another interesting thing with this case study is also that that part of this experimentations was done in the UN Pet Lab, which was established beginning of last year, and it helped provide environment where this testing could be done. So there will be two more case studies presented in a very in much more detail later in this presentation. So I will just go forward and pass to my colleague Dave. So he leads the team which is working on use cases and on case study repository, and he will explain what are our future plans in this area.
Great, thank you, Matthias, and hello everyone. So yeah, in addition to presenting the case studies in the new guide, as Matthias just described, we've also created an online repository of case studies, which will be publicly accessible and linked from the guide itself. The intent with this repository is that it will act as a very useful standalone resource, providing would-be pets adopters a bit of a kind of one-stop shop to explore some of the different use cases of these technologies, and yeah, to build on what Matthias said, learn about some of the learnings that others have found from implementing these technologies within their organizations. So currently the repository, which is sort of screenshotted here, contains the 18 case studies that are included in the guide. So yeah, you can sort of see the full list there, but I guess just to touch a little bit on a few of them, you'll see there's many use cases from national statistics offices or other government agencies. So for example, from the UK's Office for National Statistics, which details their trialling of synthetic data for private data dissemination, and also for providing test data for debugging internal machine learning pipelines, which is perhaps not such an immediately obvious use case of pets. There's also examples from Statistics Canada, where they leveraged homomorphic encryption to privately train a text classification model, and a collaboration between the Italian National Institute of Statistics and the Bank of Italy to privately link financial records to enable richer analysis. But we also have a few examples from sort of non-statistical office organizations. So for example, we have Samsung in Korea, who've explored privacy-preserving data aggregation through private set intersections. The Boston Women's Workforce Council, who leverage secure multi-party computation to measure wage disparity in the greater Boston area in the US. And as has been mentioned a couple of times already, we also have the first use case of the UN Pet Lab, which involves calculating discrepancies in trade statistics as measured by different countries. And that sort of uses differential privacy for output privacy, but also two demonstrations of using either secure multi-party computation or secure enclaves for input privacy. And I think that use case is probably particularly instructive as it showcases how different technologies can be used to achieve these sort of privacy goals, and details a bit what maybe some of the trade-offs or considerations are that you might want to consider when thinking of adopting these approaches yourselves. Yes, and as Matthias mentioned, a couple of colleagues on the call will be doing a deep dive on two of these use cases later in the session. So We intend to maintain this repository as a live resource, providing updates on the case studies as they continue to develop. And then additionally, what we're looking to do in the future is to add new examples to the repository. So yeah, where people on this call perhaps are hopefully inspired to go and use pets in their organizations, like we'd really love to hear from you about those experiments. And yeah, we're planning soon to provide details on how people will be able to make contributions to this repository. And yeah, we have the URL provided there where you can see this repository in action. So yeah, I think that's probably all I have to say. So I will pass back to Jess, I think.
Thank you so much. And now I'd like to introduce Mr. Julian Paget, Associate Professor for Artificial Intelligence with the University of Bath in the United Kingdom, who will be discussing standards.
Thanks, Jess. I think the camera's on. That's good. Let's see whether we can share. And there we go. Would you give me a thumbs up on that, Jess?
Yeah, that's all good.
Thanks very much. And do that. So in starting, I'd like to pick up on some of the words of Director Schweinfest at the start about standards not being a straitjacket, something that is going to fence people in, but rather being something to help and guide people to make the right decisions. Indeed, many standards openly go out of their way not to mandate what solutions are, but rather to help the reader to find their way to a standards compliant solution. So in that sense, they're helping to share good practice, make products shareable, and generally build up a common language for people to discuss problems across sectors and internationally. In this edition of the guide, we've considerably expanded the discussion of standards from what it was in the first version. And the reason we've done that is that we've taken a broader view of the standards that are relevant in the broader context of pets and national statistics, as we'll see in a few moments. But also it reflects the increasing pace that relate to pets. And that's driven in part, certainly in some parts of the world, by the connection between standards and legislation that is emerging. So we've broken this particular chapter down into these three parts: key standards, related standards, and standards under development. And we'll have a look at each of these in the coming slides. So the first question we might ask ourselves then is which standards might be relevant for pets? And the first things that one thinks of are the sort of underlying technologies of things like encryption that Rob was just talking about, and that appear in standards related to security of systems. But then actually an emerging area of significance is how do we manage those issues? What are the organizational factors that go into the decision making about the development of a product that might involve pets? So it becomes a matter of the governance of the product development. And of course, naturally, there are the standards that are situated around the use of big data. But I guess looking at this slide and picking out the keywords there and noting perhaps some of the numbers of these standards, you might be asking yourself, perhaps there is something missing. And there indeed has been a lot of activity in regard to artificial intelligence related standards, which we'll have a look at in just a moment. And one of the reasons this wasn't treated in the previous version of the PEC guide is that the ISO committee, subcommittee 42 for AI standards, was only established in 2018. And as you can see, there are quite a number of participating countries, and a number of standards have emerged in that time, which is largely consistent with the sort of 4-year time frame that there is between the inception of a standard as a proposal for a new work item and its publication as an international standard. So people have been working quite hard and fast on this sort of thing, as well as there being a load of other standards under development. There are, under SC42, a number of working groups to focus the activity, but the two that are most relevant to what we're talking about today are WG2, which focuses its attention on data-related issues, and WG3, which considers trustworthiness. Under trustworthiness, there are some dozen or so other sub-projects, some of which we'll mention in a moment. And SC42 also quite reasonably liaises with SC27, which is where all of the information security standards that are developed, which go back much longer. And there is also a joint working group with Subcommittee 7 looking at the testing of AI systems, where we need to think about new approaches to the testing of systems that don't have necessarily the same properties as conventional systems, and therefore are not susceptible to the same approaches to testing that we might be familiar with. And so we need, for the purposes of quality assurance, to take different approaches. That brings us to think about security standards as well. And as I said, security standards have been around for some considerable time. The SC27 was established back in 1990 and has published some 229 standards in this time. Within SC27, there are again a number of working groups. I've only highlighted a handful of them here today as the ones that sort of fall into the intersection of the activities we've just been talking about with AI and that are relevant to the PET guide. So obviously in WG2 there's cryptography and security mechanisms, and then there is also an ad hoc group which is looking at security and privacy in AI and big data. So the reason that this exists as an ad hoc group is because it's crossing committees. And so rather than being a topic that's purely situated within one. So this committee is responsible for of a large collection of standards, the 27,000 series on information security. And it publishes on various topics to do with, amongst other things, signatures, hash functions, and encryption algorithms. But also it publishes guidance on how to govern information security and how that connects up with the kinds of processes that might be involved and where PETs might be applicable within the development life cycle. So to put those two committees into a slightly wider context and to advertise exactly where these the standards are being developed and are being adopted. If we look at ISO, we've got a number of countries around the world that are members of ISO. Another large grouping of standards making activity comes under the European Normalization Committee, CEN, which there are 35 members, so there are 27 EU members plus a number of others. They mostly decide upon the adoption of ISO standards for all of those members, but also consider the creation of standards which are there to deal with particular European issues. And those two organizations, or more particularly ISO, are the ones that most people will think of first, perhaps, when it comes to standards. But then there is also quite a significant number of standards that are developed through the IEEE, which again is an international organization. And the standards making there can either be through individuals grouping together to produce a standard, or it can be through what's called the entity mode operation, where the people are actually representatives of their companies rather than individual experts. And the IEEE standards are often, if one looks at their titles, and we have some examples on an upcoming slide, they tend to focus more on quite tightly defined topics that at least they can do, or be focused on specific sectors. That doesn't mean that they don't do some widely scoped standards. There is looking at ethically aligned design, and two of the two significant standards within that series are P7001 on transparency and P7003 on consideration of algorithmic bias. So I promised that we would have a look at some examples of various standards, and some of those things that are coming and that were actually too late to make the cut for the document that is available to you today. And within artificial intelligence, there's work on a technical specification looking at the mitigation of bias in classification and regression. The reason that it doesn't that it is only looking at classification and regression is that at the moment the state of the art is suggesting that those are the machine learning mechanisms that can be handled for mitigation of bias, whereas other approaches are still a matter for research. A very significant standard that's just approaching international standard status, it's a DIS, that means it's a draft international standard, is the AI management system standard, which will provide guidance in a similar sort of way to ISO 9000 for how organizations might approach the governance and development of AI-based pipelines. And as part of that, there's a much earlier stage piece of work. You see it's in the same series, 42000, which is looking at impact assessment of a particular AI system. And then there's the assessment of the performance of classification systems, how to go about. So this connects back with the earlier discussion about how do we test such things when we have to look at different sorts of properties to the kinds of things that were there in conventional software. A fifth set of standards that are coming are looking at data quality in the area of analytics and machine learning. As you can see, these are currently at a mid stage, which is called committee draft. And there are some 5 standards in the 52-59 series upcoming on that, so they will probably be ready in a couple of years' time. And looking at explainability of ML and AI systems, this is relatively early stage. It's a technical specification rather than even being something that is will end up as an international standard. And looking at within the current work program at IEEE, there is, and this exemplifies what I meant about more tightly focused standards, there is this framework and process for deep learning evaluation, which is working group 2841. On the security side at ISO, there is an early stage now working draft on fully homomorphic encryption, a topic that Rob highlighted earlier. Part 6 was published already a few years ago, and as you can see, Part 8 is now in progress. And also quite recently, 2 draft international standards are now emerging on secure multi-party computation, again, a key technology for input privacy. Looking again in the list of activities at IEEE, there is we have, rather than a standard, we have recommended practice, So providing useful inputs to organizations about how to go about using a technology like SMPC in P2842, and similarly a recommended practice on privacy and security for federated machine learning. And then lastly, a guide for an architectural framework and application of federated machine learning.
Thank you so much. And I'd like to now introduce Mr. Mayank Veria, Associate Professor of Computing and Data Sciences with Boston University in the United States, who will be discussing legal issues.
Okay. Can you see my slides?
Yes.
Great. Okay, thanks. So in my talk, I'm going to build upon some of the stuff that Julian just said and describe some of the ways that legal, regulatory, and policy questions can influence the choice of the right privacy-enhancing technology to use, and also to underline the importance of timely incorporation of legal advice from the start of any new project. So my name is Mayank Veria. I'm an associate professor at Boston University. My research is in cryptography. I am not a lawyer, and this talk is definitely not legal advice, and neither is the chapter. Instead, the talk is the result of discussions between a broad team of a coalition that we've built of PET researchers, National Statistical Organization representatives, and data privacy lawyers. I put on this slide a list of everyone who's participated in at least one meeting of our group, but an important disclaimer up front, I want to emphasize that everything I will say today is the result of a collaborative discussion amongst this group. It does not necessarily match the views of any particular person or organization listed on this slide, and it should not be interpreted as an endorsement by any of them. So our team has done two things. First, we've written a chapter in this new PET guide that we're talking about today. And also we are in the process of writing a separate standalone report. Our goal is to describe how privacy-enhancing technologies contribute toward adherence with the legal obligations under the diaspora of privacy laws that exist across UN member states. The audience for our report is lawyers, policymakers, and data scientists construed very broadly in both the public and private sectors. So our report has two objectives. I'm going to focus in today's discussion on the first part, which is providing a general method that lawyers can use to reason about whether an application of PETs is consistent with the law. And additionally, in our report, we also describe several case studies to show how PETs can open up new affordances under the law, with an emphasis on applications of PETs that involve government statistics agencies. And in fact, the later talks after mine today will go into some of that as well. So to make my discussion a little bit more concrete, in this slide, I show an example of one kind of input privacy technique that's already been discussed. It's a tool from cryptography called secure multi-party computation. So on the left side, there are individuals, companies, and governments that input into this sort of black box thing. They can jointly perform a data analysis without the need to share their own data sets. But I'm not going to worry about the technology of how this works. In my talk, let's explore the legal and policy considerations that affect when a PET is viable to use. So in the left side of my picture, the individual people who have data are generally free to do whatever they want with their own information, but the hospitals, educational institutions, government organizations that I show in the picture are often subject to data privacy laws. And these laws, these legal restrictions, are the end result of a series of intentional choices that we've collectively made as a society that balance several competing interests. And introducing a new technology doesn't somehow magically make all of those interests go away. So in our chapter, we explore this question of when is the use of PETs consistent with the law? So just to state up front, this talk is not meant to be some kind of like legal compliance checkbox. Instead, actually, I want to say a positive thing up front, which is that PETs have several benefits that they can contribute towards regulatory compliance and achieving policy objectives. So first, PETs can contribute towards adhering to a UN member state's existing laws, norms, policies, regulations, et cetera, about data privacy and protection. And this is because PETs have intentionally been designed to provide technical data privacy safeguards throughout part or all of the data lifecycle. Second, the data privacy, Second, the data privacy and anti-disclosure protections offered by PETs can empower people to contribute their personal information towards data analyses and empower information technology organizations to participate in an analysis by reducing disclosure risks to an acceptable level. This can lead to greater representation in data products that better reflect all of society, which in turn can improve social trust in the resulting data products. And third, PETs can open up new opportunities in scenarios where data processing is desirable, but the underlying data is currently subject to statutory, regulatory, ethical, contractual, or competitive restrictions on data use, processing, or disclosure. And this is because PETs allow for revealing only those derived data products that have recognized social or commercial value while otherwise protecting sensitive data. Great. So to determine whether the use of a PET supports adherence to the law within the context of a particular scenario, one must verify that all of the participants in the scenario have satisfied all of their legal obligations. And to do so, our team recommends a three-step mission mapping process. First, enumerate all the actors involved in any aspect of data processing or technology development. Second, determine under the scope of which laws each actor is subject to, and also determine the types of affirmative requirements or limiting restrictions that those laws impose on them. And third, analyze the extent to which the deployed PET is consistent with those obligations and requirements. And finally, these considerations must be applied throughout the entire data lifecycle from idea conception to system decommission. And for this reason, it is critical that any statistics-related project must involve appropriate legal and regulatory experts when the project starts at the beginning of a project, and also whenever any meaningful change is made to the system. Because in practice, I'm going to give some general ideas and guidelines, but in practice, the legal position depends very much on the individual fact patterns of the specific project design and the specific deployment scenario. So in my remaining few minutes of the talk, I'm going to go through each of these three aspects of our taxonomy in a little bit more detail. So first, I'll provide a high-level overview of the three categories of actors to consider under data privacy or data protection laws. The first group of actors are the legal entities who are either intended to benefit from or have affirmative protections by the relevant laws. So for example, these might be the people who meet the legal definition of data subjects under the European Union's GDPR, or as consumers under various privacy laws in the United States, or by different legal terms of art in other jurisdictions. These are the actors who have certain legal rights and protections pertaining to their personal data or personal information. Second, we must identify the actors who have obligations under the relevant laws and who are typically subject to legal liability if they are not compliant with those obligations. So for instance, a processor of personal data might fall under the jurisdiction of a privacy law. And third, we must consider the suppliers of tools enabling users to employ PETs. So depending on the facts of a particular scenario, they may or may not fall under those prior two categories I just defined as well. The key point I want to establish here is that there's a difference between the organization who creates a privacy-enhancing technique, who develops a tool that implements that PET, and who offers a service that makes use of a PET. And those differences might influence their legal obligations and liability. Next, we provide a taxonomy of 4 kinds of features to consider when analyzing any kind of regulatory event, whether it impacts any of the actors. So first is to determine whether an action falls within the scope of applicability of the regulatory regime. So some jurisdictions have omnibus general purpose regulations, whereas others are more targeted to only consider a subset of the data or a subset of activities that could be performed over that data. Moreover, some laws might be framed in such a way that anyone who does or who does not do a particular legal action will be legally liable, whereas other laws set out certain preconditions or criteria that must be met by an actor before it becomes subject to its obligations. Second, we should consider how a regulatory event impacts the actor's use of data. So broadly speaking, we categorize regulations into one of 3 types. Some regulations limit disclosure of derived data products to other actors. Some restrict the actor from using the data of a particular specific protected type, and others regulate general data processing more generally. And third, we consider the style of regulation. So some regulations require the actor to take an affirmative step, like obtaining informed consent. Other regulations might require stating a concrete purpose for each action taking. Others might issue blanket prohibitions on certain uses or disclosures of data. And yet others might impose a fiduciary duty of care to consider the best interests of other actors throughout the data lifecycle. And finally, we must consider data subject rights beyond just privacy rules. So for instance, in some cases, long-term access to certain data might be necessary to comply with certain legal obligations or might be prohibited. And so even if pets improve data privacy overall, they also sometimes present unique difficulties in meeting other data obligations that exist, such as ensuring accuracy or fairness of results, or providing individuals with a proactive right to access, modify, or delete their personal data. So at this point, you might be asking the question, like, just tell me, is the use of a pet compliant with the law? But unfortunately, this is usually not the right question to ask. So few laws offer some binary, clean yes or no answer to this question for a couple of reasons. First, they're usually unaware of the existence of pets. And second, most privacy laws are deliberately designed in an analog fashion to support a spectrum of possible data protection mechanisms, and so that the law can remain relevant and flexible as technology evolves. And so for this reason, our report does not provide a one-size-fits-all answer regarding regulatory compliance. Instead, our goal is to provide questions in a mode of reasoning that guides data privacy lawyers as they assess how a particular regulatory regime impacts the use of a pet for all actors and within the context of a specific use case. So in conclusion, I want to end with 5 key takeaways. First, to reiterate, involving lawyers early in any project is strongly advised. Second is that pets can enable compliance with legal requirements, and also can, third, open up new opportunities consistent with existing laws, policies, and cultural norms. Fourth is that any activity involving data from more than one jurisdiction will be more complicated, in part because fifth, different laws and jurisdictions could take different views on the adequacy of a pet for any given use case. Thank you.
Thank you so much. And now I would like to introduce Mr. David Archer, Principal Scientist with Galois Inc. in the United States, who will discuss the case study, United States Department of Education, Analyzing Student Financial Aid Data Using Privacy-Preserving Record Linkage.
Thank you, Jess, and welcome everyone. As Jess said, I'm a Principal Scientist at Galois, and there I lead a team of cryptographic experts who develop PET solutions for both government and private industry clients. These solutions include multi-party computation, fully homomorphic encryption, trusted execution enclaves, and output privacy techniques such as differential privacy. So we have projects in all of those technologies. And in addition to that, I'm a member, as you can tell, of the UN Privacy Preserving Task Team, and also one of the judges of the Privacy Enhancing Technologies Prize Challenge, currently in progress in the US. Let me share my slides here. Jess, can you tell me, can you see those?
Yes, we can.
Great. So I'm going to talk through one use case that is talked about in the new document, but it's a use case we implemented for the US Department of Education about a year and a half or 2 years ago now, in conjunction with partners at Georgetown University, also in the US. And it has to do with input privacy preserving statistics with respect to national education statistics. So the problem that we were trying to solve in this setting, and successfully built a prototype that met all the requirements of the education department, was the following. The National Center for Education Statistics in the US has to link sensitive data between different Department of Education activities, and there are policies that prevent that data from being shared between those activities. So they need to share this data in order to compute and report required statistics that rely on data from those different organizations. And the current practice relies on legal assurance of confidentiality. So there's a third party that signs contractual agreements that says we will not reveal this data that we see to anyone, and we'll compute these statistics. Now, our goal was to compute those same exact statistics, but with cryptographic guarantees of confidentiality instead of legal assurance of confidentiality. And this is a typical problem between many government agencies. It's also a typical problem between industry members who are seeking to do business and have to use potentially sensitive data to do that business. So as an example, this is an excerpt of the 2016 National Post-Secondary student aid study from the United States National Center for Education and Statistics. And this one table computes or displays the statistics for federal loans to students and federal grants to students in about 31 categories of students. You can see things like, are they 2-year institutions or 4-year? Are they part-time students or full-time students? What is their income bracket? So all of that information has the potential to be very sensitive. So the current method of implementing those statistical computations and publishing the report is for the National Center for Education Statistics to work with the National Student Loan Data System. Each of those provides different information into the computation. NCES provides things like attendance patterns and sampling weights and student study categories, while the National Student Loan Data System provides things like student loan balances and grant amounts on a per year and continuing multi-year basis. The computed statistics are, as I showed in the table before, things like weighted average of loans and weighted average of Pell Grants for matching records across those two sets of data. But in doing this, sensitive personal financial data can be disclosed. Now, the fact of students having loans or Pell Grants, the loan balances they hold over multiple years, and even family income details are in that data set and could be revealed without cryptographic or PET protection. The solution we implemented for the National Center for Education Statistics involved a PET known as private set intersection with statistics or with computation, also called circuit PSI. And in this case, both of those organizations still contribute their data, but they do so with that data encrypted so that no one can actually look at the data or reveal it to each other. And then we use private set intersection with computation to compute those same statistics as before, including the weighted average of loans and Pell Grants in those 31 categories. And then we can decrypt just those statistical results and provide the content of the post-secondary student aid study group's report each year. I won't go into the detail here of how this privacy enhancing technology works. We can talk later about that if you like. But the outcomes of the project were all positive. We found that we were able to, first of all, reproduce exactly the statistics computed with the data not encrypted in our encrypted PET protected form. So the results were accurate. Second of all, the computation was cost efficient. There are some conditions under which privacy enhancing technologies are not very cost efficient. In this case, we were able to run all this computation on 2 AWS large instances in a period of about 6 hours to do 1 entire year's worth of statistical computations. As you can see in the graph on the right, we looked at the scalability over increasing data set sizes of this computation. We found that it scales linearly or even better in some cases up to many millions of records. Most importantly, we showed that input privacy was cryptographically assured so that we no longer had to rely on contractual obligations to keep the data private. In addition, the pilot project showed that it was easy to use these techniques without cryptographic expertise or programming expertise. In fact, we had a single statistician inside the Department of Education as a contract employee there run all of the computations on all of the data without any cryptographic expertise at all. And finally, we'd say that this example, although it didn't include output privacy technology, is certainly compatible with it. And so output privacy PETs, such as differential privacy, could be used as part of this kind of pilot to prevent statistical results from being inverted and thus reveal something about the input data. And that's our summary of the NCES project.
Thank you so much. And now I'd like to introduce Mr. Dan Bogdanov, Chief Scientific Officer with Cybernetica in Estonia, who will be speaking about the case study Indonesia Ministry of Tourism confidentially sharing data sets between two mobile network operators via a trusted execution environment.
Hello, everyone. Thank you very much for having me. I'll try to go through this at reasonable pace. So let's introduce the pain in this setting. You have several mobile network operators, and you have the Ministry of Tourism, who would very much like to know how many tourists are moving in a country. One way to do that is ask the mobile network operators on how many roaming phones they see. So that would be a great idea, unless you had this cross-roaming issue, where one roaming phone user can actually move between different mobile network operators if the mobile network operators have such contracts. So you might get overcounting. And if you want to do official statistics, then you would like to know how big your overcounting problem is in order for you to be able to give credibility to your results. So the issue is that the obvious solution would be to just take the identifiers from the mobile phones and share them between the mobile network operators or give them to the Ministry of Tourism, but they are rather personal identifiers and thus private. So there's several issues here. There may be leaks of information about the businesses of the mobile network operators or movements of people. So this is not the preferred way. So how do you approach this question at all? First of all, you can continue solving this problem without solving the known overlap issue. This will give you no additional cost, but the risk will be that the wrong data might lead to no decisions or wrong decisions. So this is by default not the best approach. However, it is a widely used approach in the world. And second, we have trusted third party, which would give one party all the phone identifiers for doing the analysis, essentially finding a set intersection, much like Dave did. The cost here would be finding that party, solving the regulatory and security concerns. That's a cost by itself. And the risk would still be that the third party leans way too much about the mobile network operators' business models and some mobility information of the mobile phone users, which would be bad because too much information leaks. And the story for privacy enhancing technologies here is the cost is still there. I can't take away the cost, unfortunately. You'll still need to find a party. You'll need to deploy the technology. It might be somewhat easier, maybe not at first, once the technology is still new.
Reduced risks compared to option 2. So you will win compared to option 2. So here's the fact sheet for our project. It was done in 2019. The end customer was the Indonesian Ministry of Tourism, and it was an actual real project. And we are very thankful for our statistical solution provider partner, Positium. I believe Erki from Positium is currently in the audience. Thanks to their work, this was an actual project, an actual customer case. And we were very happy to provide the technology to make this happen and make this work. Also, shouts go out to Baldur in the audience, who was our project manager for this, and also helped make sure that this case reached this new UN pet guide. So let's talk a bit about what did we use. We used the system called ShareMind that is used typically by service providers to help build services that get access to data that previously wasn't as easy to access. So these data owners get remote auditing capabilities. They get the chance to actually check where it happens to their data, and they get the opportunity to make sure that their privacy policies are being enforced. The recipients of the analysis, they're the users of the new knowledge. They get insights that weren't available before. So ShareMind is a tool here that creates this end-to-end secure work pipeline and gives provable accountability. Cybernetic actually makes two versions of ShareMind, one based on multi-party computation technology, one based on trusted execution. And for this use case, we deployed the trusted execution-based system that was using Intel's SGX environment and technology. And there are some nice, unique features that we have in that implementation. One of them is that data owners get separate roles, meaning that some people are data owners, some are computing parties, some are analysts, and their rights are very heavily enforced by the trusted execution environment, meaning that if you have one role, then the computer won't even let you do something else. Then we have hash-chained audit logs at the computing nodes. And as it was previously mentioned, trusted execution environment has their issues with side channel attacks. So obviously we need to use a library of analytics tools that is resistant against the said attacks. And obviously we have to bind with various data backends like HDFS for large data inputs. Pushing data minimization to the maximum is what we are aiming for here. So once we wanted to set this up, then the good friends at Positium, who know how to do location-based statistics, they developed the methodology, tested the technical solution that Cybernetic developed. They organized the mobile network operations to come together and encrypt data for the solution. They actually went to Indonesia on site to deploy. There are some good stories about that. You can seek out the Positium team, they can tell you all about it. And the system actually was deployed and operated on site in Indonesia, and they produced a report to the customer. Cybernetica built the data import tools and the analysis tools and shipped the ShareMind HI platform. So this model we've found works. We've now since been able to deploy a similar approach in other tools, other cases as well. In the report, you find one more use case that uses ShareMind HI from Eurostat for longitudinal analysis of mobility data. So that's there's things happening here that are very exciting for us, and we hope to continue to help various statistical problems be solved using privacy-enhancing technologies. Thank you very much.
Thank you so much. We have limited time for questions, which we'll now address, but please visit our website to connect with us regarding any additional questions after this event. And before we move into this section, I'd like to invite Mr. Ronald Jensen, Assistant Director of the UN Statistics Division, to give any concluding remarks before we enter into Q&A and conclusion.
Thank you, Jess. Yeah, I had some problems. Sorry about that in the beginning, but I'm back. I'm very happy. I saw I was able to follow most of the webinar, and I'm very impressed. I mean, we've been working on this guide for quite some time with a very diverse group from not only the statistical community, but from, as you have seen, from private sector, academia, and civil society. And listening to the various presentations, also very impressed with the kind of quality that is going into this guide and the various aspects that we are covering on the technical, the standards shown by Julian and the legal aspects shown by Mayang. So I'm very, again, very impressed by all the work that has been done. I'm very grateful also that all of the various communities are working with us. That's one thing that I think I might want to emphasize is that so the role of official statistics in society is also underlined and supported by the various communities, and I think that's a big plus. Finally, I really hope that we get more cheerleaders like Ron Jamin to move this forward, because that's I think what we still need to do. We have a very good good community working on this product, but we need to communicate very well. It's difficult to communicate, and I think we should spend a lot of time of communicating with all of the different actors, as also very well indicated by Mayank, how many different actors there are in the various projects that will take place. So with that, thank you, Jess. Also, thank you for moderating. Back to you. I hope everyone has a peek at the guide. I think it's a great product. Thank you.
Thank you. So there was a question about how was record linkage conducted on two separately encrypted data set from two different agencies?
Well, I can probably answer that from the National Center for Education and Statistics pilot, for example. So using this technology called private set intersection, I won't go into too much detail, but we first encrypt the common identifier, and there is a common identifier. In this case, it was the US Social Security number of the students. Those numbers are first put through what we call a cryptographic hash function. So there's a mapping, if you will, from the Social Security number to this hash value, but that mapping is not reversible, at least not so far as anyone in cryptography knows. So those values can then be used in a very specialized way through what's called a programmable pseudo-random function in order to establish where there are matches and where there aren't. And then we can proceed to do the statistic computation on the data encrypted that's associated with those numbers. There's probably a deeper mathematical treatment I can go into, but probably not in the time we have.
Thank you so much. And I would like to thank everyone for joining today. I hope you found the information useful, and I hope that you will share the information that you found most relevant and the newly released UN Guide on Privacy Enhancing Technologies for Official Statistics that has been launched today with your colleagues to advance the use of privacy enhancing technologies for official statistics. We also heard from the director of the UN Statistics Division and the Deputy Director and Chief Operating Officer of US Census Bureau that there is a great need for more experts, both engineers and legal policy experts, to help integrate privacy-enhancing technologies into the important work of national statistical offices. So as we thank you again for joining today, we also hope that you'll consider joining international efforts to advance the use of pets for official statistics.
Thank you all.
Thank you. Thank you, everyone.
Thanks. Take care.
Thank you.
Thank you. Bye-bye.